This is the J26 video, which is all about rationalizing the denominator. And when we're rationalizing the denominator, I will mention that we are trying to get rid of radicals within that denominator, okay? And so basically we're just trying to rewrite the expression in a way that it has the same equivalent value, but where we don't have radicals in the denominator. And I am sorry that the print on this page is like super small, so I'm going to write it just a little bit bigger so that we can actually see what we're doing. So what I want to do, and again I'm just rewriting this as 2 over the square root of 3. Okay, so what I want to do is I want to look at, first of all, what's that index number. So when there's not a little number written here, it's an implied 2, so we're dealing with a square root. And with square roots, remember, in order for that root to go away, or for us to be able to simplify it, that means we need 2 copies of a base under that radical. And right now we have a 3, and we only have 1 copy, right? So in order to get an additional copy, we're going to multiply by a form of 1. Okay, so remember, multiplying by 1 doesn't change the value, and we can make a form of 1 written however we want, as long as it's a number or an expression over itself, right? So again, since I need to add to whatever's under here, or combine with whatever's under here, I need to make sure I use the same radical that I used before. So again, I'm going to use a square root on top and bottom, and I need to end up with 2 copies of a 3, right? And right now I only have 1. So that means I need another copy, and I'm using a 1 exponent just to kind of imply how many 3's are under there, okay? And if I do that on bottom, I have to do it on top. And I'm going to go ahead and write it, and these are square roots, okay? So notice by multiplying by the square root of 3 over the square root of 3, I'm not changing the value because this is just 1. If I multiply my original expression by 1, it doesn't change the value. But what it does allow me to do, when I multiply this, I'll get 2 square root of 3 on top. And on bottom, remember, we can multiply radical expressions as long as they have the same root by just multiplying what's underneath them. So what this gives me is the square root of 3 squared, right? Or in other words, the square root of 9, okay? Which then just simplifies down to a 3. So this just becomes 2 square root of 3 over 3, because the square and the square root cancel each other out. Or we can think of it as I have 2 copies of a 3, and it takes 2 copies of a 3 to bring that 3 out of a square root, okay? So let's look at another one. Another one, again, I'm going to write it bigger because it's teeny tiny. I have the cubed root of 7 and the cubed root of 9. Okay, and I want to work with as small a numbers as possible if I can on these problems. So notice here I have a cube root. That means I need 3 copies of a number. So right now I have 1 9, so I could try to come up with 3 copies of a 9. And that would be okay. We could still get to the right answer doing it that way. But what I'm going to try instead is, since I know that 9 factors, I'm going to see if I can simplify this first. So 9 is 3 times 3, right? So that means I have 2 copies of a 3 within this radical. So I'm going to rewrite it. Notice I'm not doing anything to it. I'm just rewriting it. Instead of writing it as the cube root of 9, I'm going to write it as the cube root of 3 squared, right? Because I have 2 copies of a 3 underneath this radical, okay? But in order to simplify that radical, to get that radical out of the denominator, I need 3 copies, right? And I only have 2, which means I need to multiply by an additional copy of 3. It has to be the same radical. So I still need to multiply by a cube root, and whatever I multiply by on the bottom, I have to multiply by on the top, right? And since I already have 2 copies of 3, in order to get it up to 3 copies of 3, I need 1 more copy of 3. And again, I'm just writing that exponent in to show that I have 2 copies of a 3 here, and by adding 1 more copy of a 3, then on bottom I should end up with 3 copies of a 3, right, when I multiply these together. On top, when I multiply these together, I get the cubed root of 7 times 3, right? Because these have the same radical, so I can just multiply what's underneath. Okay. Oh, that's not 28. 7 times 3 is not 28. Silly Mrs. Williams. It's 21, right? And then I go ahead and simplify the bottom, right? Since I have 3 copies of a 3, that 3 comes out. Or you can think of it in terms of the cube root and the cube cancel each other. So I end up with the cube root of 21 over 3. So our goal is to come up with how many copies we have, right? How many copies we have of the base currently. The root or the index number tells us how many copies we need. And then we just multiply by however many missing copies we need on top and bottom so that it will simplify down to something without a radical in the denominator. Okay, so I want you to go ahead and pause the video, and I want you to work the first problem, the first practice problem on page 38, okay, on the next page, just so that you can practice this one problem type, and then we'll go on to the next type, okay? Go ahead and do that, and then we'll go over it. Okay, so let's look at number 1. Notice we have a cubed root of 2. So cubed root means I need 3 copies. So what we're hoping to come up with is the cube root of 2 to the cubed power, right? Cube root of 2 cubed. That way our cube root and our cube will cancel. But right now we only have 1 copy of a 2. So what I need to multiply by is a 2 that has 2 copies, right? So that way when I multiply the 1 copy that I have by the 2 copies that I need, I end up with the 3 copies that will then cancel out this radical. So that means I'm going to multiply on top and bottom by the cube root of 2 squared, okay? So that way I get a 2 cubed on the bottom. And on top, I can multiply that with the cube root of 7 that's already there because they're both under cube roots. So when I do 7 times 2 squared, or in other words, I can square my 2 first, which is a 4, and multiply that times 7, I get the cube root of 28. And then on bottom, my cubed root of 2 cubed simplifies down to 2, which is what we wanted initially, right? Okay, so these are kind of the easy cases. The easy cases is when we just have a single radical monomial term, and all we have to do is figure out how many extra copies we need, and we multiply that on top and bottom, okay? The other case is when we have more than one term in the denominator. So we have more than one term in the denominator, like here we have 3 plus 5 square root of 2. It wouldn't be enough to just multiply by a square root of 5, because then I'd end up with a 3 square root of 5, and that doesn't actually get rid of it. So what we're going to use is this idea that we can multiply by its conjugate pair. So conjugates are basically any quantity that we can write. So here we're using a quantity that is with a radical expression. So the quantity a square root of b plus c square root of d. If we want to talk about its conjugate pair, it's the exact same quantity. The only difference is I change the sign in the middle, okay? And the reason I do that is because if I multiply any 2 quantities, conjugate pairs, what happens is when I FOIL, my middle 2 terms will cancel out. And those happen to be the middle 2 terms that will have radical expressions in them. The first term and the last term should always simplify down to something without a radical. Okay, so let me show you what this looks like, and then I'll let you practice it. So on the first one, I want to get rid of, hold on, let me write this bigger again. 7 over 3 plus the square root of 5. Okay, so if I want to get rid of the radical in the denominator, I first have to look at this quantity and figure out what does its conjugate pair look like. And its conjugate pair looks exactly like this binomial, except with a different sign in the middle. So this one's conjugate pair would be 3 minus the square root of 5. And if I multiply by 3 minus the square root of 5 on top, I have to multiply by 3 minus the square root of 5 on bottom. Okay, so I'm going to go ahead and just write this out. So on top we would have 7 times 3 minus the square root of 5. And on bottom we would have 3 plus the square root of 5 times 3 minus the square root of 5. Okay, so just multiplying straight across. Okay, now I need to go ahead. I'm going to go ahead and distribute my 7, and then I'm going to go ahead and FOIL out, excuse me, FOIL out the bottom. So when I do that, on top, 7 times 3 gives me 21. 7 times negative square root of 5. Remember, we can't multiply numbers outside of radicals with numbers inside of radicals. Only outside and outside together, only inside and inside together. So 7 times the square root, the negative square root of 5 is negative 7 square root of 5. And then on bottom, I'm going to go ahead and distribute the 3 first. 3 times 3 gives me 9. 3 times the negative square root of 5 is negative 3 square root of 5. And now I'm going to distribute this one. Okay, so square root of 5 times 3 is positive 3 square root of 5. And then square root of 5 times negative square root of 5 is negative square root of 25, right? Or just 5. And now we just need to simplify. So notice our 9 is already a simplified number. Our last term, square root of 25, that's going to simplify to a nice number. So the only places that we have radicals here are our middle terms. And because we multiplied by the conjugate, we ensured that the signs would be opposites. That way that they'll cancel out. Okay? All right, so we go ahead and simplify. So I have 21 minus 7 square root of 5 on the top. On the bottom, I have 9 minus the square root of 25, which is 5. And then I just keep simplifying. 21 minus 7 square root of 5 all over 4. And then the last thing I look for is to see, does this expression simplify? Can I reduce it? Okay, and the only way that I could reduce is if every single term is reducible by the same thing, right? On bottom I have a 4, so unless something's reducible by 2 or 4, I can't do it. And notice neither of these terms are reducible by 2 or 4, so this is going to be my final answer. Okay, let's look at another one. Same idea on this next one. The only difference is we have 2 terms in the top. Okay, so when I have 2 terms in the top, it doesn't matter. We do it the same way. We look at the bottom. We're trying to get rid of radicals in the denominator. So I multiply by the expression just like it. Oh, you know what? Here, let me rewrite this. 1 plus the square root of 2 and the square root of 5 plus the square root of 10. Sorry, I just want to write it a little bit bigger. And we're going to multiply by the conjugate pair. So instead of square root of 5 plus square root of 10, we're going to multiply on top and bottom by the square root of 5 minus the square root of 10. Square root of 5 minus the square root of 10. Okay, so I'm going to go ahead and write it all together. So on top, I have 1 plus the square root of 2 times the square root of 5 minus the square root of 10. And on bottom, I have the square root of 5 plus the square root of 10 times the square root of 5 minus the square root of 10. And now I just need to multiply this all out, right? So when I go to multiply it out, I'm going to distribute my 1 first. So 1 times square root of 5 is square root of 5. 1 times square root of 10, or sorry, negative square root of 10 is negative square root of 10. And now I need to distribute my square root of 2. So square root of 2 times 5 gives me a positive square root of 10, because I can multiply the 2 and the 5 together since they're both under the same type of radical. They're both under a square root, right? And then square root of 2 times square root of 10 is going to give me a negative square root of 20. All over, and then I need to distribute this one out, right? So square root of 5 times square root of 5 is the square root of 25. Square root of 5 times negative square root of 10 gives me a negative square root of 50. And then I want to distribute my square root of 10. So square root of 10 times square root of 5 gives me a positive square root of 50. Square root of 10 times negative square root of 10 gives me a negative square root of 100. Okay, so everything should simplify nicely. Let's see what we can do here. On top, I have two terms that cancel, and on bottom, I have two terms that cancel because they combine to 0, right? So what I'm left with here is the square root of 5 minus the square root of 20 on top, and on bottom, I have 5 minus 10, right, when I simplify these radicals. Okay, so I have a couple things left to do. One, I want to see if I can simplify this 20, and two, I need to simplify on the bottom, right? So let's look at 20 really quick. 20 is 4 times 5, right? And 4 is 2 times 2. So notice I have 2 copies of a 2, so I can bring a 2 out from this radical, and notice I'll be left with just a factor of 5. I'm going to go ahead and rewrite this. So I have the square root of 5 that was already there, right? And then when I simplify this negative square root of 20, I found that I can bring out a 2. So here's the 2 that I'm bringing out, and the square root of 5 that is left over. Okay? All over, when I simplify this, 5 minus 10 is negative 5. Okay? Now notice these two terms right here, those are like terms, right? They have the same radicals. So this is kind of like 1 square root of 5 minus 2 square roots of 5. I can combine those to get negative 1 square root of 5, or just negative square root of 5, right? Over negative 5. And then a negative over a negative becomes positive, right? And then I'm just going to drop the 1 because I don't really need it. So I end up with the square root of 5 over 5. And let me just leave it like that. Okay. All right. So there are 2 more practice problems for you guys to try on the next page. So go ahead and pause the video and give those a try. And when you're ready to go over them, or if you get stuck, unpause it and we'll go over them. Okay, let's go ahead and look at the second one because you already did the first one on this page. So this one, because it's a quantity and not just a single monomial, we need to use the conjugate. And the conjugate quantity would be square root of 7 plus square root of 3. So we want to do that on top and bottom. And we go ahead and distribute the 4 on top to both of these radicals, right? And when we FOIL out the bottom, we should get these 4 terms, okay? Notice our middle 2 should always cancel, and our first and our last should always simplify to something that we can make into just regular numbers, right? So square root of 49 becomes 7, negative root 9 becomes negative 3, and then those combine to a 4. Now notice every single term has a 4, right? So since all terms are reducible by 4, we can go ahead and reduce. So I went ahead and factored out the 4 so that I could cancel it off. I'm fine with you canceling at this point as long as you know you have to take it out of every single term. Okay, so that's going to leave us with just the square root of 7 plus the square root of 3. Okay, let's look at number 3. So number 3, we need to multiply again by the conjugate. Okay, the conjugate of square root of 3 minus square root of 6 would be square root of 3 plus square root of 6, and we have to do it on top and bottom. So I went ahead and wrote it out. We're multiplying the 2 numerators, multiplying the 2 denominators. This one, when we multiply out the numerators, we should have middle terms that cancel on this one as well. Okay, on bottom, our middle terms should cancel out. So what we're left with on top is the square root of 3 minus the square root of 12, and the square root of 9, which is 3, minus the square root of 36, which is 6. Okay, so we want to see if we can simplify the square root of 12, and then we also combine the denominator to get a negative 3 on bottom. Okay, 12 does simplify because it's 3 times 4. 4 is 2 times 2. So since I have 2 copies of a 2, that means I can bring a 2 out, and I'll be left with that 3 factor underneath the radical. Okay, and now that I've done that, notice both of these are square root of 3 terms. So they're like terms. So we can go ahead and combine those, which gives us negative 1 square root of 3 over negative 3. And we don't necessarily need the 1 there, right? If it's a coefficient of 1, we don't have to write it, but we do know that a negative over a negative turns out positive, okay? All right, so that is the end of J26. So you should now be able to complete that assignment within your My Math Lab homework, okay? Let me know if you have any questions.